In this video, we'll look at units in real-life contexts. The first example is units that appear in situations involving energy and power. All right, so to kind of summarize what these units are referring to, all right, energy has the standard units of joules, right, and that one may not be as commonly known as calories. So just for comparison, 1 food calorie with a capital C is equal to 4,184 joules of energy. And energy is just a measure of what makes matter move or heat up, right? So anything that would use movement or would use heat would use energy. So running an oven, moving your body, like walking or running, things like that. Power, on the other hand, is the rate of energy. So this would involve units of energy and also units of time. Right? So the standard unit for power is the watt, right? And then watts are measured in joules, 1 joule per second. Okay? Or since joules can be converted to calories, we could talk about actually calories per seconds for watts as well. Okay, and we can make that conversion. Right, so I think you're familiar with watts, like a 100-watt bulb. Right, what that means is that it's using 100 watts or 100 joules per second. All right, here's an example. This one's personal. I was hiking in Ricketts Glen recently, and I went through the math here to figure out how many calories I burned and per second or per hour, and then I was curious to see if I could convert that to watts. So one thing that's fun to do is to see what your rate of power is, and if you would be able to power a light bulb or multiple light bulbs, and that's just kind of a fun exercise. All right, so Ricketts Glen is about 7.5 mile trail. It's pretty cool. It's in Pennsylvania. There are about 22 waterfalls, and it's steep hiking, so it's a lot of different stone steps. So what I did was I went online to sparkpeople.com and found an estimate for how many calories burned per hour for hiking if you're not carrying a whole lot of weight. Okay, so I found the data that I was burning about 621 calories per hour. Okay, and incidentally, it was about a 3-hour hike, but that's not necessary if you're just wanting to know what your average rate of power is, or how many light bulbs you could power. Okay, so what we want to do to figure this out is to convert this to watts, right, or joules per second. All right, so I can go from hours to seconds, and we can go from calories to joules, and that would tell us the answer. All right, so we know that 1 calorie is equivalent to 4,184 joules. And then let's go from hours to seconds. All right, so 1 hour is equivalent to 60 minutes, and 1 minute is 60 seconds. Okay, so if we follow the units, calories cancel, and hours cancel, and minutes cancel, and we're left with joules per second. And then if you do the calculation, 621 times 4,184 divided by 60, and then divided by 60 again, and that gives about 721 joules per second. Right? And joules per second is watts, so that's about 721 watts. All right, so the amount of calories I was burning and the rate, calories per hour, was enough to power 7 100-watt light bulbs. If you're interested, some gyms have a piece of equipment that you can attach to different exercise machines, and you can actually figure out your own wattage or joules per second. My mom was in cardiac rehab, the last few years for her heart. She had some surgeries, and she had this machine that was hooked up to an elliptical and an arm bike and a rowing machine. And when she started, it would tell you like the wattage, and then you can kind of compare that to what size light bulb. So when she started, she was at a night light level, and then went up from there to I think 100-watt bulb or something like that. Another personal example, I got 2 antique brass candlestick lights for Christmas, and I like to burn these overnight to just have some light in the house, so it's not completely dark. But I was curious, I've never actually calculated before this video how many watts that's using and what's the rate, and also what the cost is per month for me to run these things. So to figure this out, what I knew was the wattage of the bulbs, and they were each 7 watts. Okay, so I have 2 of those, and I was curious, I've been putting them on for about 12 hours a night, but sometimes I feel like I need to wait a few hours when I come home at night before turning them on, and I wondered if it was worth it to really worry about a few hours. All right, so I did the calculation here, and I'm curious to know the cost for 2 of these bulbs, which are each 7 watts, and for running these for 12 hours per day. Okay, and then I also needed to know the cost of electricity. So this is measured in kilowatts per hour, or I'm sorry, not per, kilowatt hours, okay, with a hyphen, so that's multiplied. And then I was able to go online to PP&L and figure out my current cost, and that was about 11 cents for 1 kilowatt hour. Okay, so that's what I know, and that's enough. If we do the unit conversions, we can calculate the cost for running these 2 lights for that amount of time per day for a month. Okay, so ultimately that's what I want to know. What's my monthly cost? Okay, so let's start with the wattage on the bulbs. So it's 7 watts per bulb with 2 bulbs, so that's 14 watts. All right, and then I know that the cost is calculated per kilowatt hour, so I do need to figure out, how to convert this to kilowatt hours. So we've got to get the units of time in there somehow. All right, so it is 14 watts, but I need to know how long I'm using the bulbs for. All right, so this was times 12 hours per day. Right. And then we'll just pick an average month and do 30 days per month. Okay, so if we look at the units right now, I have watts, hours per month. Okay, so I need to get watts to kilowatts. So I'll have to go on to the next line here. Okay, but I need to multiply by the conversion factor from watts to kilowatts. And I'll do a W. Okay, so from kilo just to a base unit here. Okay, so it's kilo, and then going down the metric chart, kilo, hecto, deca, and then the base unit, which would be watts. Right, so I'm going down 3 places, so I need to move the decimal point to the right 3 places. Okay, so 1 kilowatt is 1,000 watts. Or of course you may know that kilo means 1,000. Alright, so 1,000 watts is a kilowatt. Okay, so I've got the kilowatts, I've got the hours, and I want a cost per month. So I've got the per month in here, but I need to get the cost in here as well. Alright, so we can multiply by one more thing, which is the cost per kilowatt hour. Alright, so this would be 11 cents per 1 kilowatt hour. So let's check the units and make sure I didn't miss anything here. Alright, so watts in the numerator cancels with watts in the denominator. Days in the denominator cancels with days in the numerator. right? And then in the numerator, I have hours and kilowatts, which cancels with kilowatt hours in the denominator. And then the units that are left, I've got dollars here and months here, right? So my units now are in dollars per month, and that's what I wanted to know. What's the cost per month? Okay, so now you can do the multiplication, which is 14 times 12 times 30 times 11 cents, all right, or 0.11, and then divided by 1,000. Right? And if you work all of that out, this comes out to about 55 cents per month. Okay, so I'm pretty happy with that cost, all things considered. It's only a couple quarters to run these lights for an entire month. Right, so I'm good with that. For comparison, I found my electricity bill for, I think this is for July. No, this is June, I think. Okay, so this gives me my total bill for June, which is $64.32. Right, so it's not those two little lights that are the biggest expense for me per month. Okay, you'll notice here on the bill you can see kilowatt hours. So if you've never noticed that before, find an electricity bill and you should be able to see those units on there at some point. Okay, so that's my average for the month. On the back of this bill, okay, you can actually see the charge per kilowatt hour. So it's broken down. There's a distribution charge of roughly 4.3 cents per kilowatt. There's a tax cut of a certain percentage. Then there are some generation and distribution charges. Okay, and then generation and transmission charges. Okay, so all of this is adding up. That's that 11 cent estimate there. But there's also this fixed customer charge of $17.56 a month. Right, so you really can't do anything about that by limiting your electricity usage there. All right, but again, still in the whole scheme of things, a couple quarters is all right. And then notice there is an explanation. So if you don't remember what kilowatt hours are, they do explain that to you. Okay, it's a measure of how much electricity your household uses. 1 kilowatt hour equals the amount of electricity used by 10 100-watt lights. Okay, so 10 100-watt lights is 1,000 watts, which is a kilowatt, left on for 1 hour. And that just sort of puts it in perspective to give you an idea of what things would use that amount of electricity. All right, so try it out yourself. One thing you could do would be to calculate the cost for running Christmas lights for December. Right, so a typical string of the incandescent lights, not the LEDs, but the incandescent ones, they're typically 100 watts. Right, so you could go through and if you put your lights on a timer, you could calculate how often or how long you run the lights each night. You can look up your electricity costs for kilowatt hour. You can find that online, and then you can go through the math just like we did to see what the cost would be for running your lights, for how many strands you use. All right, so try it out, have fun.